Okay, so I'm doing now corrections for section 4.9 and 4.10, which start at question number 11 in the calculator part. And this is the equation or the inequality they give you. It says solve the quadratic inequality. Write your solution in set builder notation. So set builder is going to be something like this. X such that blah 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 blah, and then you close it off. So it's going to have to look like that. Okay? And we're going to pretend this is just equals for now. Okay? So we'll do that. And so the first thing I would do is try to get everything to one side. Maybe I can factor or something like this. I don't like this negative sign here. So I'm going to choose to add x squared to both sides. And then I'm going to subtract 3x from both sides. And I'll write it in standard form. So when I do that, I'm going to end up getting, that's one way to do it. Now there's other things you could do, like multiply by -1 and flip the inequality, all that stuff. But I'm just going to do it this way. Okay, this is not the only way. This is the way LaBelle chose to do it. Okay, so we got that there. I don't like how I wrote that 8. I'm having trouble with my 8s. Okay. So I got the 8 there. Fantastic. Now I need to. One option to do is just do the quadratic formula to see what your critical values are. But this looks fairly easy to calculate because it says what are the factors of 18 that subtract to 3? Well, don't 6 times 3 equal 18 and 6 minus 3 equals 3. So I'm going to write it like that. I'm going to factor it. So remember, I'm going to pretend it's equal for now. I need a 6 and a 3. I need an x and an x. And I need more negatives, so the 6 gets the negative, the 3 gets the positive. So now I know my critical value. This is not my answers, this is my critical values. 6 or -3. So if I have the number line, it's going to look something like this. Here's 6, here's -3. Now if you're not sure what works, you can go back to inequality and let's say try 0. So 0's right here. It's not exactly in the middle. I guess I should back it up there. It's a little bit closer to -3. So there's 0 there. But it really doesn't matter where I put that 0. What it is to matter is I'm going to put it in there. And if I do that, if I put 0 in here and here, that whole side becomes 0. And is 0 greater than or equal to -18? And it turns out yes it is. So that means I should probably, when I go to fill this thing in, I should probably make sure I go right here. 0 works, so I got to color everything in. Now it was an equal sign, so it's right here. There's my picture, looks like that. That's one way to think of it. The other way is just remember that when I read this, x's are less than 0. So this should be an and here. Okay, and it would be the same kind of coloring. Now what does that mean? That means x is bigger than, but it's equal to -3, and it's less than or equal to 6. So this is what I really have to put in the set builder. I'm going to write set builder x such that x is between -3 and 6, including -3 and 6, and there's my answer. Okay, so in number 12, it says state the domain of y equals the square root of everything x squared minus 5x minus 5. And the domain, it means what values are allowed for x. Now, if we wanted to graph this, we do not want imaginary numbers. That means we can't get square roots. Anything under the square root cannot be negative. So not negative means you can be equal to 0 or bigger than 0. So we want everything here to be bigger than or equal to 0. So I can drop the square root sign and just look at how do I get that. So I'm going to write x squared minus, if you wrote that, that was worth 1 point. You hadn't barely done anything except remember that you don't want negative numbers under the square root if you want to be able to graph it. So the domain is not going to include imaginary numbers. Okay, so now how do I solve this? Well, I'd like to factor it. Factors of 5 that subtract to 5, well, there aren't any. So the only other thing I do is try to complete the square, which I don't recommend doing on this. I would recommend you just use the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So I'm just going to put those numbers in. So that would be negative 5, 1, 1, and then on the very end it's going to be a c, which is also negative 5. So I put those numbers in, and I get x equals 5 plus or minus the square root of 25. Now it turns out a negative, and a negative is a positive, so I get plus 20 all over 2. I don't really need this extra square root part right here. Okay, well that's 20 plus 25 is 45. So what is the square root? So 5, it's not a 20 down here, it's supposed to be a 2. Okay, plus or minus the square root 45. Well, 45 looks like something that has a perfect square in it. It turns out that's the square root of 9 times, I can't write today. It's supposed to be a 45. I said it and then I didn't write it correctly. And the square root of 3. Square root, again, square root of 5. 9 times 5 is 45. So this is a normal 3, and this is just root 5. So this is going to actually be 5 plus 3 root 5 over 2, or 5 minus 3 root 5 over 2. And now we're not going to be done so quickly. I wrote it separately, most people don't, but this is just telling us the critical values. If you look at the problem, it was really great or. Great or means separate directions. So if I was to do the number line, it would look something like this. This one goes here, this one goes right here, and it's got an equal sign in it, so it's going to be solid. It's going to be solid, and I need to go great or in those directions. Now if you don't believe it works, let's try 0 in there. If I put 0 in here, 0 squared is 0, negative 5 times 0 is 0, and then you have negative 5. What's the square root of negative 5? Well, that's clearly an imaginary number. We got a problem here. Okay? It's clearly a square root of a negative number. So clearly this, we don't want things in the middle there. So it's definitely great or. So if I write this, it didn't say what kind of notation I had to use, so all I have to say is, I'm going to say x is greater than or equal to 5 plus 3 root 5 all divided by 2. Some people put 5 over 2 plus 3 root 5 over 2. Or x is less than or equal to, so the opposite direction, 5 minus 3 root 5. I'm going to do some erasing here. And there should be an or in there as well. So there's my answer. I was looking for this. If you didn't get, if some people got the roots fine, they got this and this, but that wasn't finishing the question. You had to explain that there are some numbers that don't work. The numbers between those don't work. Okay, I'm going to pause this and I'll upload it.